Hey there, and welcome to this video on getting started with Voxel Plugin 2. This is a video that is very quick and dirty. I'm not really writing a script or following any preset pattern. I just want to make something so that we have a bunch of information about working with the current version of Voxel Plugin out in the world for people to reference, because there's very little right now, and I want to help on that a little bit. Things are still very subject to change. This video is going to be about what will be preview release 7, so 2.0 P7, which is intended to come out at the end of the week in which I'm recording this. I am assuming that you have Voxel Plugin Installer installed and that you have a verified Voxel Plugin account. If you don't, there is a documentation page in the description which will tell you all you need to get started with that. I have developer versions enabled right now in the project settings, show dev versions, so that I can download a developer version, but you will have a 2.0 P7 entry here, and that is what I would recommend if you're watching this around the time where this was uploaded. Generally speaking, the P number releases are the stable ones, and enabling the dev versions can sometimes be a good idea for specific features, but if you want to go down that route, I would recommend joining the Discord so that you can check in and ask whether the developer releases are stable at the time you are doing this, because sometimes they're pretty good, sometimes they're really not. Anyway, I'm going to hit install. That is going to give me a downloading Voxel plugin pop-up in the bottom right, which you guys can't see because it's off screen for you. But we're just going to wait for that to come up. Oh, actually, I just realized that this menu is also half off screen. Anyway, once that's done, we get this little pop-up and we get Voxel plugin successfully downloaded. So we are going to restart and reload the plugin. So then this will do its thing. Then we can close it and the editor will automatically restart. Now for this trial project, I've got the third-person example installed, and I have the starter content. I'm going to download the nanite materials example, just so that we have something to work with in terms of materials, but I'm not going to go in depth about how materials work on this pipeline. That will be a separate video at some point, but we're also still making some changes to that pipeline, so I don't want to get too in depth about that. So the intent with this video is that we're just going to set up a basic terrain with some basic PCG based scattering. It's not going to be pretty, it's not going to be actual foliage or anything, it's just going to, work at a basic level, and we're going to add some basic gameplay functionality to the default third-person character. So we are going to start by hitting Ctrl-N to make a new level. We'll select the basic one just because it's got lighting and stuff, but not much else. And then we're just going to delete the floor. Now we have an empty scene. Let's just save this as something. Definitely don't recommend naming your levels like that. And then we have an empty canvas that we can't do anything with yet. So to get started, we are going to place a voxel stamp into the scene. A voxel stamp is what you use to tell the voxel world to generate anything whatsoever. So we'll have a pop-up come up in the bottom right, which says voxel world added to the level, and it will say that the voxel world has no mega material assigned. These are things we will worry about in just a second, but you'll see that we have a new stamp actor, and we have a new voxel world. Now, we don't have anything on screen yet, which is because we don't actually have anything assigned in this stamp. Right now, we are going to just select volume and then shape, and then we'll select a plane. This will give us a boring little plane, which we can just reset to origin, and then we have a plane at origin. We can change the size of this plane, and we can assign a material to it. Now, you'll note that these give us voxel material assets, not regular materials. This is because otherwise you'd have 100 materials in this list in a bigger project, which is not practical, so you have to specifically make a voxel material asset pointing to a regular material to assign it here. We're just going to pick one of these ones, and then on the voxel worlds, we'll still have that pop-up in the bottom right, which again for you guys is off screen, which says that we have no mega material, and that is stopping the material from being visible at all. So in here, we're going to create a new mega material. and then we'll have a pop-up missing mega material entry. On that one, you want to click add, and then we'll get shader compilation, and then the material will show up. Anytime we add a new material to the scene as part of the voxel reference stuff, it will ask us again whether we want to add that. So for instance, if I add the MI gravel, again, that'll go to the gray grid material, and we will get that pop-up in the bottom right. Again, you click add, it'll compile some shaders, and then you will have your properly blended material. It's worth noting that there's currently some issues with displacement because we made some changes to the material backend, so this does not look as good as it's supposed to. It's supposed to look like this, but in the blend areas it doesn't right now. This is something that we're aware of and we will be fixing, it's just not fixed right now. Anyway, we'll just delete that one, and then we've got this one plane. Obviously a plane is not super interesting, and to do more with that, there's different things we can do. We have different kinds of stamps, which includes mesh stamps. And in the height category, we have height maps. We have splines, which are super cool and you can do fancy things with, like making roads. But they're also quite a bit harder to work with. So to start, we are going to set this to height, and then we're going to select graph. And that isn't going to do anything because by default, it's not going to have a graph. So in here, we're going to click create new asset, voxel height graph, and we'll just make a basic little voxel height graph. And again, nothing has happened yet, which is because if we open this graph, it's currently empty. Now there's 3 pins here. Everything that actually does something in the world in voxel graphs is run through one of these output nodes. We can place any random node elsewhere. There's lots of nodes, but none of them will do anything unless they are specifically plugged into an output node. So in this case, that's an output height. For certain other graphs, that is different types. In this case, we have a height pin, we have a material pin, and we have a bounds pin. Now, the material is just the material that is assigned to the surface. The height is the height that the terrain will have at any position on the surface. And the bounds is the size of the stamp, and it will only run for positions that are inside of those bounds. So in this case, the easiest way to do that is we'll just do make box 2D from radius, and it's 2D because we're working with height stamps. And then over here, we'll drag out from the radius and we'll do promote to parameter. And what this does, it's throwing errors because it's 0. But now if we select this parameter, we can set the default to 1000. And we'll have a height of 0 and no material right now. But now you'll see that we have a plane showing up. So going from here, let me just map so that we can see both. Going from here, we want to get something other than a plane going, and also let's reassign the material that we had previously. So we can do this, and then the nicest ways to work with noise right now is to just place an advanced noise 2D node. Now there's a lot that you can do with this because there's different kinds of noise. So if we press D with this node selected to preview it, and then we zoom out. It's worth noting this is right now in the distance field preview mode, which can be a little bit weird. You can also switch it to a grayscale one, which can make more sense depending on what you're looking at. And this will show us, roughly what that noise is going to look like when we plug it in. So if we change it to billowy, you'll see that we get a very different kind of noise. Ridged purlin, again, a different kind of noise. Billowy cellular, we have a whole bunch of noises with different characteristics. And you can set a default, which is this one, that's going to be smooth purlin. But you can also override it for specific octaves. So for instance, over here we have smooth, but we can set the first octave to be ridged so that we have mostly smooth noise, but with some sharp lines inside of it. Strongly recommend fiddling with that sort of thing, but for now we will leave this mostly at the default settings. The amplitude and the feature scale are important here because the feature scale is more or less the amount of space between big features on the terrain. So right now you can see in the preview we're at 500 meters across, and that's kind of the spacing between these big mountains. And right now we don't want something that big, so we're just going to remove a 0 here, and you'll see that everything becomes much smaller scale. And then we'll do the same on the amplitude, which is the height, and all of this is in centimeters. So right now the height is 10,000. which means it's 100 meters, which is a little bit much. So we'll just set this to say 3000 instead. And again, this isn't doing anything yet because it's not plugged in. So if we just take this and we plug it into our height, we will see that our little plane is now not so little anymore. Now, this is a bit weird looking because it's tiny for the height differences and stuff. So we're just gonna go in here, and because we made the radius a parameter, it now shows in this default category. So we'll just take that and we'll increase that. And now we have our very basic procedural world, and you can see that we have these nice little ridges in it because we made the first layer of this noise ridged purlin, and then on top of that we have nice blobbier noise to just give a little bit of extra surface definition. So we now have a very basic terrain with some noise going on. There is lots of stuff that we can do in these graphs, and I'd recommend playing with these graphs if you at all enjoy this sort of thing. Use the preview, it is your best friend. We also have a viewport now, which lets you preview the result of your graph without having to actually use it in the world, which can be really useful for quick iteration because you can do, you know, this sort of thing and immediately see the results. And again, right now, for instance, the amplitude is static in here. We can make that a parameter as well, and then we can easily change it. But that also means that we can change it in here. And what's cool about that is that we can then take another one and we can give that one different settings. Now, obviously, in this case, it doesn't look very appealing because we're not doing anything particularly interesting with it. So we're just going to set that back to default. But it's good to know that that's the sort of thing you can do. Now, one fun thing that we can do here is we can take another purlin noise, and this is just a regular one. And we will do get position 2D and feed that in here. And we'll set the amplitude to something small, like 2. And we'll set the feature scale to something small as well, say 5000, so that's 50 meters. And then we can do blend materials. And so we'll browse to this one just for easy selection. And then over here, we'll do gravel and plug that in here. And now we get patches of gravel and patches of dirt. Now, this is one way to do it. It doesn't look super satisfying. One of the more common things you want to do is probably use an auto material of some sort. I'll just quickly show how that works. I'm not going to go in depth on it in this video, but it's good to know that it exists and how it works. So if you make a voxel graph type asset and you select a material graph, I'll just vmg sample. This outputs a material, and only a material. So in here we can do blend materials, select our 2 materials, and this works like a post-process on the entire world wherever it's assigned. So if we now assign, we will need to make an auto material that uses this. So over here, voxel auto material, and then we can assign a graph. And if we assign this in our height graph, right now we'll just see the big gravel being applied everywhere because we have an alpha of 0, but we can change that alpha and you'll see that update the world as well. And then of course what we can do here is that same purlin noise thing we just did, but in the material graph specifically, we also have access to the vertex normal. Which means we can break this pin, which is going to give us the normal information, and then we can work on a component level. And if you don't know, the normal is if you have a surface and you draw an arrow straight out from that surface, the normal is the direction of that arrow. And in Unreal Engine, Z is up, that's the blue arrow. So the value of this Z tells us to what extent something points up. So if we plug this into the alpha, you'll see that we have the green leaves everywhere. And on the cliffs, we start to get the rock poking through. So you can do some basic math on this. So for instance, if you multiply this by 2 and you add a little bit of offset, and let's maybe go the other way. Something like that. Typing is hard sometimes, in case you weren't aware. So we can do something like this, and now we have, you know, gravel on the slopes and muddy leaves everywhere else. There's obviously a lot more refinement that can go into this, and then you can, you know, do another blend material, so you could have different gravel in here and blend those together. For now, we're just going to leave it at this, so that we have something nice to work with, something that looks a little bit more visually interesting, but where we don't go into too much detail yet. So we now have a very basic terrain with materials assigned to it. One thing I just quickly want to touch on is the Voxelized Mesh stamps, which if we go into the starter content and we just filter for a static mesh, let's see if we have anything nice in here. I'm pretty sure there's a rock, right? So the starter content has this rock, and we can place that as a static mesh, of course, but we can also place that as a voxelized static mesh. So if we right click this and just go to this folder, we can right click it and do create voxel static mesh asset. And now if we drag that into the world, it just works. Now this obviously doesn't look especially good. If we go into the wireframe view, we can see pretty clearly that we just don't have a lot of terrain resolution. So if we scale this up, you can see that, you know, we do actually get that mesh shape pretty visible. There's two options here. For one, you know, this is actually pretty small right now. So if we go here and just assign the third person game mode to this level, if we just go into play mode by hitting Alt P, this is a relatively small rock compared to the player, but we still want a little bit more detail than that, most likely. Oh yeah, definitely do this. This is something we should do. We'll get to that in a second. In order to be able to represent shapes like this better, we're going to set the voxel size of the terrain to 50 centimeters, which is going to increase the resolution of everything in the terrain. So now if we press Alt 2, you see, you know, this is 50 centimeters, this is 100 centimeters. We just have a lot more triangles to work with. So we have our rock, and in this case, you know, this isn't the most interesting mesh. But in the example content, which you can access by right-clicking and then add voxel content, in the stamps and graph example, we have some more interesting mesh shapes that you can work with, which shows more of what you can actually do with this. If you scale it, you still get more shape just because you have more resolution to work with. But yeah, this is an interesting way to author stuff. You know, the graph workflow so far, as I've shown it, is very procedural centric. But if you are coming from an angle where you want to hand author your world, just working with mesh stamps can be super powerful, because for instance, if you would want to make a rocky environment with a cave in it, again, obviously these aren't the best meshes and everything, but we can just rotate this down so that it's a nice little blob-like shape, and then we can put this on, say, a scale of 2 and make it subtractive. And then just like that, we can start making cave environments. Let's make this a little bit bigger and then grab the subtractive one. Now, right now, the lighting is pretty terrible on this, which is because we have Lumen disabled. So let's go to the voxel world and click Enable Lumen. And now you see that the voxel world starts doing nice luminy things. You can make sure that this is all working properly by going here and then selecting the Lumen overview. It should look like this. It is worth noting that at the moment that I'm making this video, we don't support hardware ray tracing. So if this is blank and over here in this yellow text, it says HWRT instead of SWRT, that means you're using hardware ray tracing. If you go into your project settings, you can use and search Lumen. Over here, you can set use hardware ray tracing when available to false. That is grayed out if hardware ray tracing is disabled in your project. In that case, you don't need to do anything. But if this is not grayed out and it is ticked, you want to untick that, because otherwise the voxel world will not be able to affect Lumen. Anyway, ignoring that, we now have a cave that is actually nice and cavey and has a little bit of lighting going on in there. And again, we can keep stacking these. So right now we have that one. We can just add another one. We can add another one of these. Move that down here. And like that, you can start to make more complicated shapes. And the nice thing with this is that it's just so much quicker to iterate versus having to manually sculpt this entire environment. And that does make a pretty big difference in my opinion. And again, you can set smoothness values because this is all distance field based. So, right now this is set to 100, but if we increase this, you get nice blobby shapes in all of your interactions. And again, the same we can do here. We can increase this smoothness and that will give us a really nice soft blend with the rest of the terrain. Anyway, there's a lot that we can do on that front. So that is where I'm going to leave it for the actual terrain creation for starters. I would recommend playing with height graphs, especially. They're quite straightforward to work with in terms of math and that sort of thing. We also have graphs on the volume side. Those are a bit more difficult to work with because it's working with a distance field. So I'd recommend that does require a little bit more of a math background generally. But we have some really good resources for that on the Discord. Lots of people doing fun stuff with that sort of thing. So if you do want to get into that, I strongly recommend joining the Discord and asking questions there. What we're going to do next is we're just going to set up a very quick PCG example for this world, which is not going to be super interesting, but it'll get the point across. So we're going to make a PCG graph. And then we're going to drag that into the world, and we're just going to set it to origin. And we're going to increase the scale a bunch so it actually covers the voxel world properly. And now this doesn't do anything by default. There's a couple of things that we need to do before PCG will actually play nice with the voxel world. The first is that we're going to go to the PCG component here, and then we're going to get generation trigger and set that to generator runtime. That is going to make it so that it updates when a voxel terrain updates. We're going to enable is partitioned, which allows it to work in chunks so that only little bits will be updated at a time rather the entire thing being invalidated whenever we make any small change to the terrain. And then on the PCG world actor, we're going to tick treat editor viewport as generation source so that this all also works while we're in the editor view instead of only working while we are in play mode. Now, this still doesn't do anything because we don't actually have the PCG thing doing anything. So we're going to select the PCG component again, and then we're going to open the PCG graph that we created. Over here, we want to enable use hierarchical generation. That is a related setting to the partition one. It's just something we need to enable for this to work properly. And then we are going to do a voxel sampler. Now, this is a little bit of PCG boilerplate, but you want to give a bounding shape here with the grid size because we don't want to generate this in the entire world and we don't want like duplicate points, blah, 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 blah. PCG is a bit complicated to get into. We have lots of clever people getting into that on the Discord, so if you have questions about that, I strongly recommend joining and having a chat there, and also looking at the example we have for PCG. Again, you right click, add voxel content. We have a PCG sample that both scatters some basic shapes and stamps, because you can also spawn stamps like those rocks from PCG. In this case, we're going to keep it simple. We're just going to do this. This is needed to make the grid size work, to make it so that we spawn in small chunks. And then we're going to do this. Over here we have a stack and a layer. We have a bunch of documentation on this topic, which I will link in the description. It isn't relevant for straightforward use cases, but it controls the order in which stamps are executed. And when you start doing more complicated things, you want to create your own stack and add more layers to it so that you can work, with a layer type concept like you would in, for instance, Photoshop. So this should just work out of the box, really. If we select this and we press D, we should see all of our little cubes show up, because this is what previewing something in PCG does by default. Now, ideally, we want those cubes to actually exist in the world versus just being there as a debug visualizer. So we can do a static mesh spawner, and then in the mesh entries, we can go into the descriptor and we can select the bush that is included by default. And now if we hit D, you'll see that we have our little bush being scattered everywhere. Now there's a lot of stuff you can do in PCG itself, but there's also a lot of cool stuff that you can do on the voxel graph side here, and I just quickly want to show that. So if you go here and you do call voxel graph, this won't do anything yet, but over here we can create a voxel PCG graph, vPCG sample, and by default this is just going to take the input point and produce output points. But in here we can do all sorts of fun math. So for instance, we can apply translation. And you'll see that this moves our points just up or down, which isn't super interesting, but it's just a nice little utility. And a lot of this sort of thing is more straightforward to do in voxel graphs than it is in PCG nodes. But another nice thing that you can do here is, for instance, set point rotation. This sets them all to 0, which we may or may not want. In this case, by default, points in PCG are aligned to the slope. We might want to filter the ones on steep slopes, in which case we do get point rotation. And then again, we're going to get the up vector, which is the same as the normal that we used for generating where our materials go. So we're going to split that one, and then we have a Z component. And in here, we can use a density filter and plug that in. And then we can just plug that into the output. And you'll see that our points start to disappear. Now again, we'll probably want to do some math on this. So let's do this, for example, and this is all just, you know, math fiddling. Just enter some numbers and see what you end up with and what sort of numbers you like. In this case, we're being pretty aggressive with filtering out all of the stuff on steep slopes. I think this works pretty well. So we're going to do set point rotation at the end here. But now they're all the exact same rotation, which again also doesn't look very good. So I'm going to split this rotation, and then the yaw, which is turning on its own axis, so just rotating where it faces, we're going to do a random float. And we're going to set this 0 to 360, because 360 degrees is full rotation. And then over here for the seed, we're going to plug in get point seed, because every point has a unique seed. And that is going to give us a random rotation per point. And we could do the same for scale as well if we want. So if we do apply scale, we can do a random float again. And then we can just do, say, 0.8 to 1.2. Convert that, which it will automatically do when you connect it. And now we have a little bit of randomized scale in there as well. If you are more familiar with PCG, you can also just set point attributes, get point attributes. All of the attributes from PCG are automatically passed in here. Something that we can also do is right now we use the slope directly to filter, but we could also just get the material weights, because if we go in here and we select this and press A, which is another debug mode that PCG has, and we select one of these, this is all of the attributes that every point has. And at the end here, you'll see we have our voxel materials. And these are the weights that each of these has. So I can just filter based on the weight of the gravel layer, because really that's what we want to do. That's already slope based. So if we get point attribute here, and then we do VMMI gravel, and right click this, convert it to a float, and then we can use that as the density filter. But now we have the opposite effect, where things are only spawning on the gravel. So what we want to do instead is we want to use the muddy leaves one. And if we have a look here, it now does make more sense with the cliff shapes, but we probably also do want to do a little bit of a multiply and shift just to control exactly where the cutoff between the two ends up being. So if we do times 2, and say plus 2, we want to subtract because this is just adding more of them back to the cliff. There we go, I think this is pretty good. Now, one thing that is worth mentioning is if you want more points, you can control that from the actual PCG graph. Over here on the Voxel sampler, we have these settings. I've already changed them a little bit from the default, but by default, they're like this. This controls how many points we originally generate. And so it's 1 every 100 centimeters, so 1 per meter. And then this is how many we filter out. So in this case, 0.1 points per square meter means 1 point every 10 meters. That's not how that math works because it's squared, but it's fine. So 1 point every so many meters. I usually prefer just setting this to a very high number, so we don't filter any points like that, and we just control the cell size to decide how many we want. So we've set the cell size to 300, and that lowers the resolution that we are actually placing the points at. So we end up with a bunch of floating points like this. Now, in order to fix that, we can do something in here. We can also do it in the PCG graph. There is a voxel projection node, which does the same as the projection nodes in PCG, more or less. Or we can do that same thing in the voxel graph, where it's called ray march. So we will do ray march layer distance field and just plug that in. There's a bunch of settings on here that you can control, but you don't necessarily have to. And now you'll see that all of those floaty points are actually nicely slapped to the terrain. Sometimes you still get a little bit of floatiness with these points, and to compensate for that, we have that apply translation set to -10. If we set this to 0, we do end up with a little bit of floating, especially on slopes. So if we just, sink them in a little bit, that ends up looking good. Then the one thing that remains that I want to show on this side, because it's a little bit confusing sometimes, is if we want to have meshes that are controlled by the voxel graph, we want to select the PCG static mesh spawner node, and we want to change this to selected by attribute. Now this is going to look for a static mesh in an attribute. By default, that's going to throw an error because that metadata doesn't exist. We're going to change the name that it looks for to static mesh. And it's still going to error because it still doesn't exist. But then over here, we can do set point attribute, static mesh, and then we can plug that in. Now, this is currently a wildcard type, a gray pin, so it doesn't know what type it is, and we have to tell it what type it should be. In this case, and this is a quirk of the PCG integration that we have, we need to specifically set this to a soft object path. So if we select soft object path here, it will now show us every single type in the engine, which is rather annoying. But if you scroll all the way down, you get a search, and then you can just search for the object that you want. So in this case, we want static mesh bush. We're going to assign that and just plug that in here. And now we'll have our bushes back. But what we can also do on this front is we can drag this out and do a random select. And again, we have a seed field, so we'll plug the get point seed in there to make sure that it's different for every seed, for every point. And then over here, we have a static mesh array or a soft object array. We can use a make array node to do it statically, or we can use promote to parameter, and we'll call this static meshes. And we can plug in weights to this, which would be a second float array, or we can just leave it like this, and then it's going to randomly select one, pretending they're all the same weight. So in here we can just assign our static mesh again, and if we hit Ctrl F5 to force a refresh, because for whatever reason that didn't automatically refresh, we now have the bushes being generated again. But because this is a parameter, it's also visible over here. So in here we could say we also want some of these balls spawned here and there. And now it's going to randomly select between those two for every point. But again, because we have the material weights, we could also, in the beginning, instead of filtering based on the material weights, we could use this little bit of math. So if we just move this, and then we will do a select, and I'm just going to be a little bit cheeky and do this the way you shouldn't really. So we're just going to get 0 and 1 from the array. if this is more than 0.5, for instance, we switch. So now our bushes are on the slope. I actually kind of want that to be the other way around. I think that looks nicer. So now we have weird glowy orbs on the hills and bushes on the flat surfaces, which I think is pretty neat. It's obviously not perfect. It has some quirks, but this is a good starting point. One thing that you can do if you want to be fancy with this is you can do a random float per point. No, not make seeds. Hello, get point seed. Do it to 1. And this will add a little bit of randomization to that. So that rather than every point being that, it is slightly randomized which ones are going to be replaced. So you still have a little bit of bushes on the edges and stuff. But that is details. That's just how you do far-off math in this sort of graph. Anyway, if we clean up this graph a little bit now, which is to say we're going to just untangle the nodes a little bit. We now do a density filter, which isn't relevant anymore because we're not slope filtering anymore. Then we ray march to make sure that all of our points nicely snap. We offset them downwards a little bit, and we randomize the rotation. We randomize the scale, and then we pick a static mesh based on whether there is a mud material or a gravel material. That's pretty much all I want to show on the PCG side. You can also spawn voxel stamps. For this you use the voxel stamp spawner node. So to do this in the stamp settings, need to select which layer it assigns, which layer it is on, and then you need to make sure that that is not the same layer. It's a layer that comes later than the one that you're sampling from to spawn them. So yeah, that gets a little bit fiddly. Not something we're going to get into the details of right now. So we just have this working at a basic level. And if we just hit play, we will have a character. Now, what you guys can't see in the bottom right is that I'm getting errors about my voxel character not being a voxel character type. It is a regular character, and that causes issues. So we get all of these. To prevent that, you really do want to make sure that you are using a voxel character, because you will see your character teleporting around if you don't. So on a blueprint class, just select it, and instead of character, use voxel character. If you have another parent class, you can manually copy code from the voxel character into your own, if it's a C++ class, or you can set the parent class of whatever blueprint parent you have to still be voxel character instead of character. But at whatever point you're inheriting from character, you want to inherit from voxel character instead. With that said, we've converted that, which means we should now just smoothly walk around. By default, the editor waits for the world to be generated before it actually starts simulating the player and everything, so you shouldn't fall through the world ever. So yeah, this should all just work. Now, the runtime sculpting API is currently unfinished, so I'm not going to show how to do that. But what we can do is if we do, is it LMB, left mouse button, and then we're just going to be lazy and do it at the actor position or like right below the actor position. So we're going to get actor location and then minus 80. What we're going to do to make this work is we're going to add an instance stamp component to the character, and it doesn't matter that this moves around, because anything we add to this is going to hold a bunch of stamps that we spawn at runtime. Anything we add to this will be in world space, so it doesn't matter that this is attached to the play component. But if you want, you can attach it to something else as well. And then on here, we're going to do add stamp. This takes a stamp. We're just going to promote this to a variable. And then on here, we're going to do make copy, so that we don't accidentally modify properties on the variable. And then we're going to do set transform. And we'll split that pin This is all fine. We don't need to like rotate this or anything. We just want to do that. And then we're going to spawn that stamp. And now we have this stamp parameter where we can just select whatever we want to spawn. So in this case, we'll just spawn our rock thing, and that'll be spawning below the player. Oh, but we have it set to additive, which means it's inside the player. That is not what I meant to do, because then the player immediately falls through. So we want to set it to subtractive instead. And now you'll see that will slowly be digging a hole, and you'll also see that PCG immediately updates. Depending on your PCG settings, you can disable those sorts of automatic updates, so that the foliage only updates when you specifically want it to, or so that foliage just doesn't update, you only remove instances or some such. But that is a little more complicated and more PCG related, so kind of not in scope for this video. One other thing I want to show on the gameplay side, which I won't actually demonstrate, but we have query voxel layer nodes, which let you query materials, which let you query metadata, and this is very useful because you can just insert a position, or in the case of the multi-query, you can input multiple positions, and you will get a result, which is the distance or height, depending on whether it's a distance, a volume, or a height layer, and the material. If it's a distance, the negative value means you're inside the surface, and a positive value means you're outside of the surface, so in the air. And this just allows you to check, what is the material that I'm currently trying to interact with, what material am I standing on, so that you can do physical material style footstep sounds or some such. Or you can query any generic metadata, and that is one thing we haven't touched on yet. If you, for instance, want to have a stamp which doesn't affect anything but it just masks foliage, we can place this rock into the world, and that obviously places a rock, which in this case isn't really what we want. But if we go here, we can disable shape and we can disable material. And in here, we have metadata overrides. And metadata is just any random data that you want to store on your voxel world. So we'll do VFM sample, and this will create this, and it writes 0. Now obviously this does nothing right now because we're not doing anything with that in any place. But if we open vPCG sample again, in here, if we re-add that density filter that we had in the beginning, we can do get point attribute VFM sample. Now it's going to complain because we don't actually have this assigned right now, because we need to specifically tell this voxel sampler to query that metadata. So we're going to do that. And now we'll hit Ctrl F5, and it still isn't doing anything. And the reason for that is because we just created this, but by default metadata has a default value of 0. So that means that right now we're setting the density to 0 everywhere. So if we regenerate, you'll see that we now have foliage nowhere, everywhere except where we put this stamp. And right now we're using this mesh stamp, but we could also, for instance, use a sphere stamp, which will reset the metadata overrides, which is probably something we should change the behavior of. And then the smoothness on here controls how gradual that transition is as well. So you can do a lot of fun stuff with metadata. You can sample this like this. But one other fun thing that you can do with this, which I just quickly want to show, is all of this is available on the material side as well. So if we just open the master material that we're using here, I'm going to get material attribute, set material attribute, and we're going to add the base color on both of those. And then we're going to do get voxel metadata. And then we can select that asset, and we can just do this. And if we hit apply, this is going to automatically generate a texture to sample this metadata in the material wherever we need it. So any area of the terrain that has a material that requests that metadata will automatically generate textures in the backend, and that lets you just sample any metadata in your material as well as on the gameplay side. So this means that you can use it both for foliage masking, but also to then affect your terrain materials for extra dynamic materials. So that's super cool. This is all runtime modifiable and stuff as well, because again, you know, if we're spawning those stamps, if we go into the player thing, right now, if we play and we remove stamps here, it'll stay black because we're not modifying the metadata. But if we open our stamp here and we add a metadata override to this, and we make sure to compile this. Oh, we're not allowed to set metadata. Well, if we were to be able to set this to 1, and then we spawned these stamps, you would again get your full brightness material over here, and then we would also get foliage spawning in those spots again. So there's a lot of cool stuff that you can do with metadata, and I really recommend exploring that. You can use it to do color variation and that sort of thing. Because again, on the PCG side, you can then just get your metadata and you can pass that in as per instance data using this here. And then this will feed per instance custom data into your instance static meshes. And then you can access that in your foliage materials to, for instance, match your foliage colors to the ground color. So there's a lot of cool stuff to be done on that front. You know, heck, we can even just do that. If we do VFM sample, it'll find that one and it will now be writing that. But of course, because we have these bushes and stuff not using that in the material, that's not going to do anything yet. If we just select this, so we've opened this material and we do per instance custom data. This is a bit of a special Snowflake material node. You need to work by indices. It doesn't have names, but this is the first one we're adding to this array, so it is always at 0. And if we now apply this and we look at the world, we're not going to see anything because we are removing it wherever we have this thing. So if we reopen VPCG sample and we remove this density filter for a second, you'll see that our bushes here are now black. So there's a lot of really cool stuff that you can do with metadata, and I strongly recommend exploring that, both for gameplay purposes as well as really cool visual type of things. I'm going to leave it at that for this video. If anybody has any questions about any of this, feel free to drop a comment. I'll try and monitor them. But really, if you have any questions, if you're doing cool things, experimenting with the plugin, trying to learn things, trying to understand, you have any questions at all, I would strongly recommend hopping on the Discord. Lots of really cool people there, lots of knowledgeable people that have been using the 2.0 previews for many, many moons now. So there's a lot of really good information there and a lot of good input and creative people. So I strongly recommend joining that community, and we will monitor there as well to quickly respond to questions. So usually we reply to things pretty quickly there. So yeah, if you want to reach out to us, have any questions, reach out to us there. And hopefully you have fun with the plugin and let us know your thoughts on how it all goes and what you get stuck on, because we're still very much trying to improve the whole onboarding flow. So yeah, hope to see you around. Thank you for watching, and see you in the next one.